Now we'll be moving on to chapter 3.5, which is on property tables. On property tables. Okay. So for most substances, the relationships among thermodynamic properties are too complex to be expressed by a simple equation. Therefore, properties are frequently presented in the form of tables. Okay, and some thermodynamic properties can be measured easily, but others cannot and are calculated using the relation between them and measurable properties. So I'll be discussing about them. Now, what is listed in the property table? All these values that is in graphical manner, which is very difficult to read by graph, are actually fitted into tables. And this table actually obeys H equals to U plus PV. Okay, I just show you one of the table. Okay, we will go to the table. Where do you have to go to the table? Now, let's go to your textbook. Okay. You are now at property tables, right? Chapter 3.5. Okay, how to go to your table at the back of the textbook? Okay, this is your chapter. Yeah, so we're going to look at the back of your textbook. Very easy. You just go to the last page and go to the appendix. Okay, so in appendix, can you see all this list? You have table A1, which is the molar mass. Yeah, I'll just go through and I'll bring you to table A4. Yeah, I'll go through one by one with you. Okay, table A1 gives you the molar mass, gas constant, and critical points of properties. You remember the critical point that I discussed just now? You know that point where this point, this is a critical point. Up here. Yeah, this one. This one. What is the value for different substances? It's all listed here. That's the critical point. Okay, so for air, what is the formula? What is the molar mass? What is the gas constant? R value is the gas constant. The critical value is all listed in table A1. Next, we move on to table A2. Table A2 gives the specific heat for the various common gas. So what is specific heat? In your chemistry, you would have learned your Cp and your Cv. Now, what is the Cp and Cv? Yeah, you know also latent heat, right? Oh, too many terms, you may get confused. Okay, let's go to the basic thing. Okay, remember this graph just now I explained to you? Okay, your Cp and Cv will be this region. Yeah, valid for this region. Okay, Cp and Cv. Whereas this region is your, oh, sorry, I accidentally exited, yeah. Your latent heat will be for this region. Can you understand now? Yeah. So Cp and Cv is for when there is a delta T. Okay, when there is a delta T. Do not get panic with this. Don't worry. In chapter 4, we'll be looking at all this value again. Yeah, that will be your Cp, Cv. Cp if your okay, now it's okay. You can just look at it in chapter 4. Okay. Now table A2 continues with table A2b, where it is still CpCv, but this is for various temperature for common gases. Okay, so this one is for air, this is for carbon dioxide, this is for carbon monoxide, hydrogen, nitrogen, oxygen, and so on. Okay, next we have table A2C. Yeah, different substances. Can you see the formula up here? Cp with a cap here, A plus Bt plus Ct square plus dt cube. Okay, what you have to do is you have to form an equation like 28.9a negative 0.1571b and c. You just have to fit in all the values into the equation, plug in, and based on that, now this value is over kilomole, yeah, so you need to multiply by the mole and you get the value of your Cp. Okay, next we'll be moving on to table A3. Table A3 just gives you the boiling data, the freezing data, and the liquid properties for certain common liquid solids and food. Okay, so you have argon, benzene, brine, all this listed chemical compounds. Okay, and this is table B will be for continuation, but a bit more unique. Aluminium at different temperatures, density, bronze, and so on. Okay, and there are foods here like banana, beet, round, broccoli, butter. What is the freezing point? What is the above freezing? What is the below freezing? What is the latent heat of fusion? And so on. Okay, now we'll be going into table A4. Yeah, this is what we are looking at. In table A4, okay, come back to the lesson here. Okay. Where are we? Let me just look at this. Okay. Okay, table A4 gives you the saturated liquid and saturated vapor state. Okay, now what is the saturated liquid and saturated vapor state? Let's look at this. You remember the curve just now? Yeah, we had the curve just now, isn't it? The curve that goes this way, right? So this value, this line is your saturated liquid line, whereas this line is your saturated vapor line. Yeah, you agree? Okay. So, and then we have the critical point, which is at the tipmost, isn't it? Yeah. So, whatever the value that is on this line until the critical value will be for your liquid, and whatever that's after the critical will be your gas, which is given by Vg. Liquid is given by Vf. Now, this is if the graph is TV graph. Yeah, we can also have PV graph. Remember, the curve will be just slanted. Just now was this side, right? This one will be this side. From the previous lesson, I explained to you, isn't it? Okay, now how to read the values. Okay, when you go to your steam table at the back, yeah, you will see that there will be a Vf value and Vg value. Vf value is for the line that's on the liquid region, this region. Okay, now this Vg value will be the one on the gas region. Okay, so very simple. You go to the temperature that's given and then put a ruler and you can read it as it is here. Okay, that's how you do. Now the difference between Vg and Vf, it means the middle region here. Saturated liquid vapor region, right? So this region in the middle here will give you the will be given by Vg minus Vf. Okay, so that is how you interpret the steam table. It's called the steam table. As good as the steam table. Okay, now this is what you have in your textbook, right? Okay, now we're looking at table A4. We just pick one. Temperature is kept constant. This is the corresponding pressure to the temperature. And then we have the specific volume, which is Vf, Vg. Okay, and then we have the internal energy, which is U. Yeah, internal energy is U. Enthalpy is H, and entropy, something which is totally new to you, which is given by S. Now you see, you have UF, UG. You have HF, HG. You pick a calculator. Yeah, you pick a calculator. What you need to do is, let's say you pick a value here. Okay, put a ruler. Sorry. Oops, I didn't want that place to be highlighted. Yeah, I'm just picking 50 here. I highlight 50. Okay, I highlight 50. I take the ruler. I put this value and this value. You will see these two values. When you minus, you will get the middle value, which is 2233.4. You don't believe me? You take the calculator and you minus it now. Okay, what is this UFG? UFG, HFG, SFG will be the value of SG minus with SF, or HG minus with HF. That's how you interpret this whole thing. Now remember, you see, look at this. It's all divided by mass. Why? What's the reason? So that this table can be used for question which is 100 kilogram, or can be used for 20 kilogram, or can be used for 30 kilograms. So it becomes a very universal table. So that's the reason why it's given in the value of specific. See, it's written here, specific. Okay, so now, oh, sorry, it's still on the highlight. Yeah. Okay, I'm going to remove the highlight and I'm going to move on to the next page. Yeah. Oops. Okay, so we're going to move on to the next page. Next page will be on table A5. Look at table A5. Just now was T set, right? Now it is P. P is constant. This column is constant. Okay, and then corresponding T set. Okay, and then we have the same thing. Specific volume, internal energy, enthalpy, entropy, and so on. So this is table A5. So I've explained to you table A4 and A5. Now we're going to move on to the next one. Okay, so saturated liquid vapor mixture. Where is the region? It's right in the middle here. So when it's saturated liquid vapor region, of course you have a percentage. So the percentage is actually represented by quality X. Yeah, quality X. What is quality X? It is mass and vapor to the total mass of mixture. So when you have 0, it is totally at this point here, which is 0 of vapor. When you have 1, it means it's 100% vapor in this region. Okay, so when you're progressing from this side to here, you will be approaching 1. Okay, so what is X? X is vapor divided by your M total. Okay, so let's look at how you use to find the X value. Okay, so the X value will be here. You can also take V average. Remember what's V average? You have your VG minus, what is this? This is your VG, VFG is your, wait 1 second. Here, your V average will be this, the region that you need to calculate, the A to B. Yeah, A to B. Okay, and then we have VF. VF is this reading here. Okay, divided by this whole thing. Okay, so that's how you calculate your X value. Yeah, I will show you an example now. Okay, I will show you an example now so that you will understand it better. Okay, so this is how it is. VF, HF, VG, HG. Yeah, so this is for refrigerant. So careful, look at the table behind what I showed you. Table A4, A5 is for water. So you need to look for if refrigerant is the further other tables that you need to refer to. Okay, practice on one of the question. So we have a question here, example 3.1. It's from your textbook. Pressure of a saturated liquid in a tank. So a rigid tank. What is a rigid tank? It means it's fixed, or you can say fixed volume. Yeah, not moving. The volume doesn't change. Contains 50 kilogram mass, yeah, of saturated liquid at 90 degrees C. Determine the pressure in the tank and the volume at the tank. So what do? Yeah, you have to go to table A4. Very simple. You go to table A4. Let me just go to table A4. Because the question has actually given you in what? Okay, let's see. Question is given in temperature. So temperature is constant. So you need to go to temperature table. So this is 205. Okay, you have to go to 90. Okay, look at where I'm placing my highlighter. I 90. I'm placing at 90. Okay, I'm trying to highlight here. Okay, I hope you can see because it's a PDF. Yeah. Okay, once you have done with 90, what else they need? They want you to read the pressure. So what is the pressure in the tank? Just read it as it is. The neighboring number here, 70.183. So 70.183 is the answer. That would be the pressure. Okay, the pressure. Okay, so let's look at the answer. Yes, it is 70.183. Next, they are asking what is the specific volume at saturated liquid. They want at saturated liquid. Saturated liquid is VF, right? Okay, go to VF. Where's VF? Go there, put your ruler there. This is the value. Now remember, this value is actually in specific. Yeah, the value is actually in specific. So what do? You take the reading, you have to multiply by 50, because 50 is the mass that's given in the question. So when you multiply, you cancel off, you get the exact volume in the tank. So that is how you solve this question. Okay, so now I'm going to move on to 3.5. I've done 3.5. Yeah, I've done 3.5. Yeah, let me see. Okay, I will still have to cover a bit more in 3.5. Okay, let's move on to the next one, which is superheated vapor. So which is the superheated vapor? Remember, the line that is above the saturated vapor line. Yeah, anything that is beyond this line. Yeah, that is the superheated vapor line. Now, how to know if the value is superheated vapor? So there are a few clues that you need to look up at. If the pressure is lesser than P set, if the temperature is higher than the T set. So what is this P set and T set? So these are the T set and P set. Can you see this corresponding value? Okay, so if I give you a case, let's say example, the question is asking you at 25 degrees, the pressure is 40 kilopascal. So what does it mean? At 25, 40 kilopascal means it is superheated vapor. Okay, because look at this. Look at the lecture note. It says what? Oh, lower pressure is superheated. Sorry, lower pressure is superheated. Higher temperature is. So I'm going to repeat the question. Okay, if I have at 25 degrees, if I have a pressure of 40, it means it is compressed liquid. Yeah, it is not superheated vapor. Okay, it is compressed. But at 25, if I have a value of 1 kilopascal, it means it is superheated vapor. Okay, now if I reverse this, I look at another case. At 101.42 example, my temperature is 90. So if it's 90 means what? It can be compressed liquid or saturated liquid vapor. It can be lower. Yeah, because you're referring to the graph. You understand it or not? You're referring to the graph. If any value that's lower means it be falling into this region or this region. Okay, so that is how it works. Yeah. Okay, now let's look at this again. Let's go back to the lecture. Okay, so these are the criteria that you need to memorize. Yeah, these are the criteria that you need to memorize. Higher temperature than Tsat, it will be superheated vapor. Lower than Psat, P saturated, it will be superheated vapor. And then, of course, any value that's greater than the G values. Because the G values is the border here, this line. Yeah, this line. And here, isn't it? So, if it's greater than the G value, then of course it is superheated. That's how it goes. Yeah. Okay. So, next will be compressed liquid. So, compressed liquid will be the opposite side. Where's the compressed liquid? This side. Okay. So, everything will be reversed. Just now, pressure is lower. Now, pressure is greater. The temperature is lower than Tsat. And this one all will be F, lower than the F. Okay. So, these are all will be the compressed liquid region. Okay. So, which table do you go and look for it? Yeah. Which table do you go and look for it? Okay. Now, let me just show you. You go to your steam table. I'm going to make this smaller so it's easier for you to see. So, table A4 is more of saturated water. Okay, and then you move on. Saturated water. This is temperature table. This is saturated water pressure table. This is all water, yeah. A5, saturated water, pressure table. And then now we're going to go on to the superheated water. Superheated water. So, look. There is individual pressure that's listed here. So, you have to look for the pressure. Then, based on that, you look at the temperature. So, you see there's no VF, VG and all this. Oh, no, it's only VUHS. Yeah, because it's on this region, right? So, VF and VG is actually this area. So, when it's beyond, it doesn't have all this VF and VG. Okay, so that's the reason why it's like that. Yeah, okay, so this will be your superheated water table. So very simple. If you have a question of 900, okay, you take a ruler, you put it 900, and then you can immediately read 54 for V. So if the pressure is 0.015, if the pressure is 0.110, then you put your ruler, you extend it to here, this column. Okay, so that's how you read these values. Okay, so this is superheated. Next will be compressed liquid. This is still superheated. This will be compressed liquid. Again, pressure up here, pressure sensitive, and then you have temperature here. Put your ruler and then you read accordingly. So you have your V, U, H and S. Of course, all these values are being represented this region. Yeah. Oh, sorry. And the value will be represented in this region because it's compressed liquid region. Okay. So let's look at one example, yeah, so that you will understand it better. Okay, we're going to go to the X value here. Pressure and volume of saturated mixture. Okay, rigid tank. Once again, the volume is constant. We have 10 kilograms of water at 90 degrees, and if 8 kilograms of water is in the liquid form, the rest in vapor form. So out of 10, we have 10 kilogram in water is in liquid, and of course 2 kilogram in vapor. Determine the pressure in the tank and the volume of the tank. So what we have here? Okay, they want the pressure and the volume. So how do you find the pressure? A rigid tank contains saturated mixture. So they have actually given to you saturated, yeah. Okay, at 90 degrees. So you go to the steam table, which is table A4. Yeah, go to the steam table A4. Okay, now you have to move this, sorry. Yeah, you have to move this thing, your textbook. You go to table A4. Okay, you go to table A4. You look up for 90 degrees. There, can you see 90 degrees? Okay, so okay, let me just highlight this and erase all this. So now, when you have your value, so you can just read up what is the saturated value. The first question is actually asking you the pressure. So you take your ruler, you just highlight here, you get the pressure, which is 70.183. Yeah, for 90, 70.183. Okay, that's done. So the first part of the question is settled. Okay, next part B is actually asking for the volume of the tank. So for your volume of the tank, you remember what they say? 8 kilogram is in liquid. So the balance 2 kilogram is in vapor, right? Okay. So what do you have now? You go back to the table. You take a ruler. Okay. You highlight. 1 second. Okay. Now you take your ruler. You place your ruler. You read here. Yeah. You have your VF and your VG. Okay. So your VF is for liquid, 8 kilogram. You have to multiply. Remember, this is specific. So that's the reason why you need to multiply and you need to convert it to the actual volume. Yeah. So that's the reason you see they are multiplying. Okay. And then you take your VG reading, you multiply. So you get the volume as 4.73. And also you can determine what is the X value. Yeah. X value is percentage, right? So what is the gas divided by the total? Gas is 2 kilogram. So your X value is 0.2. So that's how you determine. Okay. So did I answer all the questions? Yes. Done. We have answered all the questions. Okay. Or another alternative method, yeah. Alternative method, yeah. If you know the X value, yeah. Just now you multiply 8, multiply, and then you plus with 2 multiply, right? Okay. Is to use your standard formula. This standard formula is given by the textbook itself, where you take your VF plus X multiply with VFG. What is VFG? VFG is your VG minus VF. Yeah, you multiply with the X. Okay, so X is 0.2. And then you plug in the values, you get 0.473 meter cube per kilogram. And then you need to multiply by 10, of course, to actually convert it back to 4.73. So with that, I'm actually ending this video for chapter 3.5. I will see you in the next video. Yeah, now this one is just a reference, you can just read up. Yeah, I'll meet you in the next video. Thank you.